All right, welcome you guys. So we are going to go ahead and start chapter 7. So we're going to do 7.1 through 7.3. I'm not going to do the other sections. It looks like there's 7.4 and that's it. Okay, so in these sections, we're going to talk about what's called conic sections. So you can see from the picture here that we have some cones, right? So this is called a double napped cone. So conic sections get their name from taking a plane, slicing a plane through space, right? And having it cut through this double napped cone and all the different things that could happen if we did that. So if we have a plane that's parallel to kind of the ground, if you will, although these cones go on forever. We can't really draw forever. So just to let you know, they're going on forever. But if we slice parallel to right now, what is the ground, you would end up with a circle. If you tilt that plane just a little bit, it'll no longer be a circle. It'll be probably what you've heard of as an oval, but really in this class is going to be an ellipse. Okay. If we slice perpendicular to the ground, then we end up with what looks like two parabolas. And like I said, these are going to have arrows on them because we said just a second ago that the cone goes on forever, which means that these two parabolas, if you will, go on forever. Now, this is called a hyperbola, and each one of these is called a branch. So this would be a branch of the hyperbola, and this would be a branch. Then if we slice parallel to the side of the cone, then we should only cross once and get a parabola. So these are all of the conic sections that we're going to be paying attention to in the next 3 sections. Okay. Now we get some other cross sections when we do, slice through a double napped cone. They're boring, to be quite honest. So these are called degenerate conic sections. If we sliced like straight down, it doesn't show the plane here, but imagine you're slicing it from above in half. So the plane would look something like this, and it's gonna be like that. Okay. Then it would touch in 2 lines like you see here. Okay. Or if we sliced just perfectly on like this, right? Or we sliced the paper through right there, then we would just get a single line. And then if we slice the paper right here, it would just be a point. So super boring, right? We've already talked about lines in great detail, and points are just as really, really boring. There's nothing to be said there. So we're not going to study the degenerate conic sections. Okay. All right. So we're going to start in 7.1 with the parabola. Now, we've already talked about a parabola a lot, but this is going to be almost unrecognizable because when we talked about the parabolas before, we talked about standard form and vertex form. So let me just kind of remind you guys of those. Oops. So that way they're all straight in your mind. Okay, standard form. Vertex. So to remind you, standard form is when it's just ax squared plus bx plus c. And then the vertex form, you like vertex form because you can see the vertex really fast. Always H comma K for the vertex, right? Okay. All right, so we're going to do something called transformational form. So our third way of looking at a parabola. And on top of that, we're going to add parabolas that open to the left and to the right. So far, we had only done parabolas that face up or face down, but now we're going to add to the left or to the right. Just to kind of talk about that a little bit. Let me just make a new slide here. If we end up having, well, let's talk about in the past and we'll compare it to what we have now, right? In the past, if you had y equals an x squared, you knew that it faced up. And if you had y equaling a negative x squared, you knew that it faced down. Well, in this section, we're not going to be isolating like the y. We're always going to isolate the squared term. So we'll kind of look at it through this lens. If I isolate the squared term over here, I'd have to divide the -1 out. So we would end up with x squared equaling -y. So in this section, I'm going to say, if you see x squared equals a positive, I'll say this, if x squared equals a positive, it's going to open up. If x squared equals a negative, it's going to open down. And then we're going to add in if y squared equals a positive, or if y squared equals a negative. So if y squared equals a positive, it's going to open up to the right. And then if y squared equals a negative, it's going to open up to the left, just like you would think. So positive meant up, negative meant down, positive means right, and negative means left. I think that makes a lot of sense. Okay, now the actual definition of a parabola is kind of interesting. It is the set of points that are equidistant from a point and a line. So for example, if I just gave you a line and then some point, and I said, okay, I want you to find all of the points that are equidistant to that. Most students can find this one, that one, and forgive me if I'm not perfect, but equidistant meaning this distance and this distance are equal. So that would be one point, but it turns out that there's many points, like maybe right here, I want to make this the same distance as that. Maybe if I can just eyeball it, like right here, I want this distance to be the same length as the perpendicular distance there. Anyhow, if you drew them all, guess what you would end up with? You would end up with a parabola. I should be able to have one over here, where this and this are the same. If I mirror this guy over here, find my best and eyeball. Oops, I think that needs to go a little higher. There we go. This distance and this distance, 1, 2, 3 should be the same. Okay. And there's going to be infinitely many of them. Okay, that's the best I can draw that there, you guys. So forgive me. All right, so I used to get problems like you're buying a new house and we live near the 15 freeway here, so I'll have the 15 freeway. And let's say your job is right here. This is your work. Let me make it a, that's the definition there. And you want to buy your house so that you're the same distance from work as you are from the freeway, something like that. Okay, so where would your house be, right? And so it would be along, some parabola, like so, because these would be equidistant. You pick some other point, assuming I drew the parabola correctly, those would be equidistant. So yeah, that's our technical definition of a parabola, the set of points that are the same distance from a point in the line. All right. So some of these we already know. We're pretty familiar with the axis of symmetry. We know the axis of symmetry slices down the middle of the parabola, making it symmetric on both sides. And we already know where the vertex is. You've been dealing with that a lot. Now that we already said for a parabola, the point and the line, it's equidistant from them, right? So that means whatever this is, this has to be the exact same. Well, that is what we call P, okay? The focal length, if you will. Technically, it's the absolute value of P because distance should always be positive, right? So I'll put some absolute values on that. Okay. All right, now this line is called the directrix. Blatantly say it was on the last slide. And this is called the focus. So in those satellite dishes that you've seen, like when someone has the dish and they have that little ball out here, that ball is actually called, I'll dash that, but that ball is actually the focus. Okay. All right. So I think that's all we need from this slide. All right, so we're going to start off with parabolas that are centered, that their vertex is on the origin. Okay. So in these pictures, you can see that all of these have their vertex on the origin. Now, like we said, if it's x squared, we know that if it's x squared equaling a positive, it's going to face up. If it's x squared equaling a negative, it's going to face down. These are all of the y squared parabolas. So we said if y squared equals a positive, it's going to open to the right. And if y squared equals a negative, it's going to open towards the left. And we have the formulas over here for the focus and directrix. Okay, so we'll just come back and use these. I like to graph first. It's easier for me to do it graphically, so I'll show you both. Okay. Now, I'm going to show you something from a previous textbook that I've used that it's easy for me to get an additional point this way. But know that the feature book and my math lab, if you click like view example, they aren't going to show you this. But I wanted to show you it because I feel like it's easier than the method that they're using. Okay, so first of all, we have a parabola. We know that the focus is always going to lie inside. Well, the line that goes through the focus and touches the parabola, that is going to be called our focal diameter. It's kind of like the diameter of a circle. It also goes all the way through, right? Okay. So this is really a great name, focal diameter, because it goes all the way through like a diameter does, and it goes through the focus. So that's why we call it a focal diameter. So the focal diameter, whenever you have in transformational form, any kind of parabola, it looks like this. The number that's in front of the non-squared term, one of them will always be squared, and the other one will not be squared, okay? Well, the number that's in front of the non-squared term, that's the 4p that they're talking about. You're just basically going to absolute value that number. So you know that's going to be your focal diameter length, or that's going to be your focal diameter. So if you know that it's 8 all the way across, well, we're always going to divide that 8 by 2. So that way we know to go 4 this way to find this point. And we know to go 4 this way to find that point. Okay. Get that off for that specific case, right? That's how we'll get the additional point. And so I'll show you both ways, because I know that students that click view example, they get upset with me when I've gone rogue and taught like my own way because it doesn't match up with the view example. So I will kind of show you both of them just so that I'm not confusing it, and let you pick which one you like more. Maybe I only like this more because we tend to like what we learned first more. But it just seems like there's less guessing this way, but you take your pick. Okay. All right, so find the vertex, focus, and directrix, then draw the graph. Okay. So let's go ahead and do that. All right, so the vertex for this is going to be 0, 0. Let's make sure that's really simple for you. Normally, or not normally, but a lot of the time, there will be something after the y and something after the x. You'll notice, in this case, nothing follows the y and nothing follows the x. So that's why 0, 0 is going to be the vertex. In the case where something does follow it, it's really easy to get the vertex. These are coming. Make sure you write x first. A lot of students will accidentally put this one first, but we know in a point that x goes first. And remember, anything in the parentheses has been lying to us all class long. We always change its sign, and that's still going to be true. So this one will be a positive 4. Okay, so that's how simple getting the vertex is, you guys. Just make sure you change that sign, right? So if nothing's there, it's going to be 0, 0. And these first few examples are going to be 0, 0. All right, now this is y squared equaling a positive. So think for a second if you can remember which way that's going to face. So hopefully you either guessed up or to the right, because those are positive. So remember, it's x squared if it faces up. All class long, x squared has faced up. So y squared must open to the right. All right. So let's go in here and get the focus and the directrix. Now, there are formulas for it. And if you want to take that approach, go for it. Okay. But I'm going to go pick by picture first. Okay. All right. So I graphed 0, 0. Now, every time you're going to set whatever's in front of the non-squared term equal to 4p. Let's go back and see why I do that. On both formulas right here, whatever's in front of the non-squared term is 4p. whatever's in front of the non-squared term is 4p. That's the reason why we're setting whatever's in front equal to 4p. And we'll do that every time, so you'll get used to it. All right, so p is 2. That's how far away you're going to go in each direction from the vertex. Now, keep in mind, we open right. So I'm going to go 2 spaces this way, and this is going to be where the focus is. I know it's the focus because we said it faces right. And so the focus will always be inside the parabola, okay? And then I'm going to go 2 spaces the other way, and that's going to get me my directrix. All right, so what I'm going to do here is I'm going to go ahead and put p equals 2. So we knew we went 2 both ways. Now, as far as drawing the graph now, the only thing I'm missing is, I don't know how wide to make my parabola. I mean, I know it opens to the right, but is it like that? Is it a skinnier one? And so that's where this second part is going to come into play. Now, before we do that, let's go ahead and write down what our focus is, okay? So we can see that our focus is at 2, 0. I'm just going to write this for a second and erase it because we're going to do it the formula way. And the directrix is x equals -2, okay? I won't erase that. Okay, so if you want to do the formula route, right, let's go back and check out the formulas. All right, we had y being squared. So we want to use p comma 0 for the focus and x equals -p for the directrix. And it'll always be like this, you guys, where the focus will be the positive p and the directrix will be the negative, or this one will be the plus, this will be minus, okay? And for like memorization, if you want to make it easy, if it's going to be y that's squared, then it's going to be all about x's here. Notice it's x equals, and this is in the x position, okay? If this had been an x squared, then it would have been all about the y's. I would have placed the p here, and this would have been a y equals, okay? All right, well, we know p is 2, so let's go ahead and substitute into. Okay, that's what we had for our focus, looking good. And then if we do x equals -p, then x equals -2 would be our directrix, which we also call. So we found the first 3 things. So now for the width, there's kind of 2 schools of thought, right? So for I think what the easier way is to get the focal diameter, because that's super easy. It's just me taking the number in front of the non-squared term and absolute valuing it. In this case, it's already a +8, so it's not going to do anything. But in the case of a -8, you'd have to absolute value it. So if we take 8 and we divide it by 2, then that means that we're going to have to go 4 from the focal diameter. 1, 2, 3, from the focus, sorry. 4 up, 1, 2, 3, 4 down. Remember we said we didn't know how wide to make our parabola? Well, now we do. Now, because we went 4 in each direction, right? Then that's going to make this line right here be 8 long, right? Because we went 4 here, we went 4 here. So that means that this line should be 8, which it's supposed to. We just got done saying that the focal diameter should be 8. So that's a quick way to get a couple more points to see how wide it goes. Now, the way that my math lab has you doing it is it kind of has you just t-charting. So when you look at, it's kind of easy on ones like this. It just gets really hard on the later ones, in my opinion. But you basically want to pick an x in this case. And you have to kind of try to pick an x that's going to make this nice, because we're going to have to square root in a second. So if I put like a 1 in, 8's not like perfectly square rootable. It's not a perfect square. But if I plug a 2 in, that should be good, right? Because if we substitute a 2 in, we're going to get y squared equals 16. And then when we square root both sides, we get y equals ±4. And what's funny is, guess where these points are that we just got? We got 2, 4 for the top one. And then we've got 2, -4 for the bottom one. which is exactly what we got using this method. Okay, let's try another one. All right, now we're supposed to have the x squared term isolated. This is the formula that we're working towards, right? If we go back to that first slide, inside of the formulas, it's always that the squared term is by itself. So I want to try to make it look like this on this particular problem. Okay, so in order to do that, I'm going to multiply both sides by a negative 12. Because if I multiply by a negative 12, then this negative 12 and this negative 12 should cancel, just leaving me a 1x squared. Or in other words, just leaving me an x squared. And then negative 12 times y is negative 12y. Now I'm going to flip this around so it's easier on the eye for us to see that now it does match this particular equation. All right, now there's nothing after the x and there's nothing after the y. So we know our vertex is going to be 0, 0. So I'm just going to graph that in our graph. All right, now it's x squared equaling a negative. P is negative. So that means that this is going to open down, just like it has been all class when we had a negative x squared. Okay. To get the p, don't forget you set 4p equal to whatever's in front of the non-squared term. Okay, so let's divide by 4 to both sides. And we get that p equals negative 3. Now we said this opens down. So I would go down 3 to get to my focus and up 3 to get to my directrix. So we could get the answers to these just right now. That's going to be the line y equals 3. So we have our directrix. And that focus down there is going to be the point 0, negative 3, right? But let's say that we want to use the formulas. Some people really like that. I want to show you both. You can take your pick. We said if it's x being squared, it's all about the y's. So we put the p in the y spot, and it's going to be y equals negative p. All right, we found p already to be negative 3. So 0, negative 3. Perfect. That's what we have. And then y equals negative 3. So in other words, y equals 3 for the directrix. Okay, so we got everything it asked for, but we still don't know how wide, how wide is our parabola. So let's go in and get that. So the focal diameter just take the number in front of the non-squared term, absolute value. So the focal diameter is 12. So 12 divided by 2 means that we're going to have to go 6 in each direction. All right, so 6. So let's see, 1, 2, 3, 4, 5. I kind of ran out of space, but 6. And then 6 this way also. So now we know how wide make it. So this one would be at the point 6, negative 3. And this one would be at the point negative 6, negative 3. And that's going to make our focal diameter 12 long because we went 6 and 6. And so that's going to add up to the 12 that we know we want. Okay. So if we use the other way, just to kind of make sure that setting you up for success if you want to do the My Math Lab way. Okay, so then if our equation is x squared equals negative 12y, well, we have to think what would be a good value for y to plug in. If I plug in a 1, well, it's not going to be good because 12 is not square rootable. 2 times 12 is 24, still not square rootable. 3 times 12 is 36. So, but I don't want 3 because that'll give me negative 12. So how about negative 3? Okay, so let's go do the math. Negative times a negative makes this a positive. So now when we square root, we won't get an imaginary, we won't get I, right? We don't want to have a negative 36 there. So x equals plus or minus 6. Oh, by the way, those are the points we have, right? It's positive 6, negative 3, and negative 6, negative 3. Okay. So we have to isolate the squared term. So we're going to have to get rid of that negative 4. So we have y squared equals negative 4x. Okay. So we can tell that our vertex is 0, 0, because there's nothing behind y and there's nothing behind x. Since it's y squared equaling a negative. So remember, x squareds are up and down. They have been all class. So y squareds are left and right. Because it's negative, it's going to open to the left. So we're at 0, 0. Let's go and get p. So remember to set the stuff in front of the non-squared term equal to 4p. So we get that p equals negative 1. All right, so opens left. Okay, so negative 1 would be where the focus is. And over here at 1 would be where the directrix is. So it looks like we have x equals 1 for the directrix. And then we have negative 1, 0 for the focus, right? Let's do it the formula way. Okay, since it's y being squared, it's all about the x. All right, so p is negative 1. And then if we substitute a negative 1 in for the p here, it would be negative 1. So we would get positive 1. And that matches with what we already knew just by doing it by picture without having to use any formulas. Okay, so we don't know how wide our parabola needs to be. So let's look at the focal diameter. So we're going to absolute value the stuff in front of the non-squared term. So the focal diameter is 4. So if we take 4 and we cut it in half, we're going to be going 2 each way. So up 2 and down 2. So now we know how wide our parabola is going to be. And that will give us a focal diameter length of 4 like we want because we went 2 and 2 in each direction. Okay. All right. So if we do it the other way, and we're looking at y squared equals negative 4x, let's try to pick, no, the reason why I'm saying we have to pick a good value is because my math lab doesn't allow you to graph fractions. It only allows you to graph perfect, integer values. And so it can't be something that's not going to square root to a nice number. So in this case, we'll be picking x's, and 4 is already a perfect square, but I just don't want it to be a negative 4. So if we pick a negative 1, that should do it. So let's kind of go through the math here, and see what we get. So y squared equals negative 4 times negative 1. Y squared equals 4. What's your plus or minus? So y equals plus or minus 2. All right, so you'll notice those are the points we had. If we go to negative 1, positive 2, that's this one. And if we go to negative 1, negative 2, that's the other one. Okay. All right, so hopefully for one centered at 0, 0, you're feeling pretty good about how to draw it. Okay, find the equation of a parabola with vertex 0, 0 and focus 2, 0. Okay, so I know this about my parabola. It has to open to the right. So if it opens to the right, we know that that's going to imply that it's a y squared equaling some sort of positive, right? So it's going to be this formula. You can just go back to that first slide where we have the formulas. It's got to be either x squared equals 4py or y squared equals 4px. And that's because we know that the vertex is 0, 0. Okay, so we got y squared equals. Now, remember, the distance from the vertex to the focus, okay, that is the absolute value of p. In this case, since we went to the right, it really is positive. But if you had gone to the left, it would have been negative, or down, for example, would be negative. So p equals 2. So we just need to substitute that into the formula. So it looks like we're going to get y squared equals 8x as the equation for this particular parabola. Okay, example 3. So let's go ahead and kind of draw a picture of what we have so far. So we know that we have a parabola with a focus at -7, 0, -7. So let's pretend that's -7, and that's where the focus is going to be. Okay. Then we're going to have our directrix at +7. Something like this. So let's think about what we know. Well, then we know that our parabola must face downward because it always has to open towards the focus. So the fact that it faces downward tells us that it's x squared that we're going to have. But it also tells us that p is negative. So it's going to make it face downward. Okay. All right. And p, remember, is the distance between either the vertex and the directrix, or the vertex and the focus. Okay. So that distance is 7, but we just got done saying it has to be negative since it faces downward. So we're just going to substitute that -7 in. Let's see what we get. There we go. All right. So what we're going to move on to now is parabolas that aren't at the origin. They'll be centered, or they'll have the vertex at h comma k, which could be anywhere. So this changes the formula a little bit. Okay, it's pretty much the same formula, but remember, since the vertex is h comma k, there's going to be a -h with the x and a -k with the y. Same thing here, a -h with the x and a -k with the y. And it does change the focus and directrix to include a little bit more. Remember, before it was 0 and then just p, but we're not centered at 0, 0 anymore. So we're going to have h comma k plus p, or in this case, h plus p comma k. So there's still the whole idea of if it's y being squared, you're going to be doing it to the x value, right? It's all about the x. If it's the x being squared, then it's all about the y, okay? And it's still plus positive p for the focus, minus p for the directrix in both cases, plus p for the focus and minus p for the directrix. So let's go try some of these. Okay. So one of the things that students tend to miss for the vertex is they will give me 5, -2, and they won't realize that x has to go first. So that -2 has to go first, and that +5 has to go second, because remember, ordered pairs are always x comma y, okay? All right, and we have y squared this time, and it is equaling a positive number. So that means if it's y squared, it's either left or right, but since it's positive, it's going to open to the right. Okay. All right, so I'm going to go to -2, 5. That's going to be where the vertex is going to be. Make sure that's 5 squares. Yeah. Okay, so let's go and get the p. So 4p, we said equal to the stuff that's the number that's in front of the non-squared term. And we're going to go ahead and divide by 4. So we get that p equals 2. Now remember, this opens to the right. So if I go 2 to the right, I'll get my focus. And if I go 2 to the left, I'll get my directrix. Okay, so that's going to be the line x equals -4. And the focus looks like it's going to be at 0, 5. I'm going to erase that because we're going to do it with the formula too. Okay. All right. So let's go in here and use those formulas for the first time. So it's always h comma k, you guys. You just have to decide if you're going to be adding the p to the h or to the k. All right. So since it's y being squared, then everything's going to happen to be x. And it can either be an x equals or a y equals, but we said since it's y that's squared, it's going to be an x equals. And don't forget, if it's a plus p for the focus, and it's a minus p for the directives. All right. So the h comma k, I know I labeled these x comma y earlier, but these are your h and your k, you guys. So -2, and then plus p, and then comma 5. And so that gives us exactly what we thought, 0, 5. I like it visually better than doing all these formulas. I think about formulas is they're easy, but then I feel like if you ask me in a month, that I'll be like, what formula? You know, forget it. And so I like to do it visually. It's a little bit easier, I think, to remember if you ask me a month from now. All right. Easy come, easy go. So if something seems easy, it's going to disappear easily. All right. So -2 is the h, and then we have to do minus p. So that ends up getting us x equals -4. Perfect. All right. So we got our vertex. Boy, that sure looks like a R. Make sure that looks more like a B. Okay. All right. And now we just don't know how wide. So let's go get the focal diameter. So we have to take the absolute value of the number that's in front of the non-squared term. If the absolute value of 8 is 8. So our focal diameter needs to be 8 long. We divide that by 2, we get that we need to go 4 in each direction from the focus. So 1, 2, 3, 4 up. 1, 2, 3, 4 down. Now we know how wide to make our parabola. And that gives us the focal diameter of 8 long, since we went 4 in each direction. Okay. All right, so then the other way, and this is why the method in the teacher book is kind of tough. It's a little bit hard. I mean, coupled with the fact that my math lab only allows integer values and no fractions, because that's what makes this tough. If it would just allow for fractions, then we wouldn't have issues here. Plug in any x you feel like. But we're trying to pick a very strategic x that's going to give us a perfect square so we don't end up with an ugly number, okay? All right, so let's think about this. Okay. Well, 8 times 1 is 8. That's not square rootable. 8 times 2 is 16, huh? Okay, so what if we pick 0 for the x then? Because 0 plus 2 gives us the 2 that we want. So we're going to put 0 in for the x, and then let's hammer out all the math over here. And the math gets a little bit more trickier when we're not centered at 0, 0 as well. Okay, so we get y minus 5 squared equals 8 times 2. Or y minus 5 squared equals 16. We're ready to square root. So we get y minus 5 equals plus or minus 4. So I'm going to move that 5 over to the other side. So it's going to become a positive 5 when it shows up on the other side. So 5 plus 4 gets us 9. And 5 minus 4 gets us 1. And what do you know? This point right here is 0, 1. And this point right here is 0, 9. So, you know, I'm a big fan of this focal diameter way. I just feel like this was a lot of math here, but use whatever works best for you. All right. So all of these parabolas so far have been given to us in transformational form. Let's take one that isn't and put it into transformational form. So you are going to have to complete the square in order to do that, okay? Let me just kind of remind you of our goal. So you can see that the x is being squared. Because the x is being squared, this is what we want to work towards. We want the x minus 8 squared equals 4py minus k. So I'm just getting this from that list of formulas. It's either going to be this one or this one. Since I saw that x was squared, I chose this first one. Okay. So since that's the goal, what you can see right here is there's a perfect square. So we're going to have to use the completing the square formula to make that happen. Okay, so we want all the x's on the left, just like on our goal. And then the other terms, we're going to shift over to the right. So we're going to move this over and this over. So it should be a negative 4p, negative 4y, and a positive 7 on the other side. Okay, so let's go ahead and complete the square. So we have to use half of b squared. Our b is going to be the number 2. So half of 2 is 1, and 1 squared is 1. So we are going to put a +1 on both sides of the equation. So whatever you do to one, you got to do to the other. Now, it's been a while since we've completed the square, so let's just do like a quick crash course reminding us, okay? You can try to factor this in the ways that we've been doing all class, where you do the x and you say, what are the factors of the last number that add up to the middle number? Well, 1 times 1 is 1, and 1 plus 1 is 2. So that means it must be x plus 1 and another x plus 1, or x plus 1 squared, right? Okay, so that's one way of getting the left side. But we said earlier in class that there's a much faster way. It turns out that this moment right before the squaring, this moment right here, that this number, this +1 you see, is the same as this +1. So I'm just going to draw a little arrow to remind us that we can just steal that number and we don't have to even think about all this stuff. Okay. All right. So then we have negative 4y plus 8. So we're slowly looking like the goal. I mean, as far as the left-hand side is concerned, we're there. We just got to make this right-hand side look like that. Now notice there's nothing in front of the y. So I'm going to have to take out a negative 4 to make it look like that. And now we look like what we want to look like. Okay. So if we go in and we get the vertex, we know that it's going to be -1, +2. So we're always changing the signs. And then because it's x squared and it equals a negative, well, all class long negative x squareds have face down. So this is going to open down. Okay. All right. So let's go get the p. 4p equals the number in front of the non-squared term. We're going to divide by 4. P equals -1. So we're going to go down 1, and we're going to go up 1 for our directives. And that's going to make our parabola face downward. The last thing we need to know is how wide to make the parabola. So let's go in and get our focal diameter. So remember, the number in front of the non-squared term, you always have to absolute value it. So it's going to be 4. So the focal diameter is 4 long. We divvy that up between the two sides. It looks like we're going to have to go 2 to the left. Oops, sorry, I'm not at focus. 2 to the left and 2 to the right. And now we know how wide with our parabola. Okay. All right, so that will give us the focal diameter of 4 like we wanted, because 2 plus 2 will give us 4 long. All right, so let's go look at that from the other way, the way that my math lab or the teacher book was doing it. So we have x plus 1 squared. So here's what I'm thinking. I am thinking 4 is already a perfect square. I just can't have a negative on it. So I'd like for this part to be -1, because a negative times a negative will turn that into a positive. So when I think about what number will make that a -1, a +1, well, go do the math. There's a lot of intuition doing this method that hopefully you can develop. So -4 times -1. So we'll square root both sides. Don't put your plus or minus when you square root. So we've got x equals, or sorry, x plus 1 equals plus or minus 2. So we'll move that 1 over to the negative, over to the other side, making it a negative. So we got x equals -1 plus or minus 2. -1 plus 2 is 1. And then -1 minus 2 is -3. And we will notice that those are the points we got. We got 1, 1 here. We got -2, 1 here. So that looks spectacular. Let's practice another one of those just for the completing the square piece, well, especially for that, because that could be kind of tough. All right. So we're going to move, this time it's y being squared. Oops, sorry, this is y being squared. So our goal in this case is actually the other formula. We want the y minus k squared here. There. Okay, so we're going to get all those x's out of there. We're going to move them to the other side, changing their signs. Okay. Now you can never complete the square with the leading coefficient. So this 4 is going to have to go. So we can factor it out in this particular case pretty nicely. All right. So let's go ahead and complete the square. So our b is going to be 4. So half of 4 is 2. 2 squared is 4. So it just gave us 4 back. Okay, so I'm going to put a plus 4 here. And so there's a lot of ways to handle this particular problem. I kind of want to show you one way because we got lucky here that everything's divisible by 4. So let me show you this, and I'll show you what I would do on this particular case. So a lot of students make the mistake of going plus 4, but we didn't really add 4. When you distribute this 4, you get that we added 16. So you would have to remember to do a plus 16 over here. Okay, that would be the hard part if you were going to be doing this with this method. Okay. Now on this particular problem, there is something kind of nice though. So let me back it up before that plus 4 business. Okay. Notice we could divide by 4 to both sides, and then we wouldn't have to deal with that situation that we were just talking about. 16 divided by 4 is 4, and 64 divided by 4 is 16. So now you really could do the just plus 4 and plus 4 because there's no number out front multiplying. So on this particular case, that's what I would do. But I did want to show you the other one because it's not always the case that 4 goes into both of them, guys. That's actually kind of rare. Okay. So remember, we can factor that thing on the left, but we said it's always the number right before the squaring, which means I'm going to put a 2 in right here, a positive 2. And when you think about it, 2 times 2 is 4, and 2 plus 2 is 4, so it worked. And then over here we got -4x plus 20. We're almost to the goal. You just got to factor the -4 out because there's nothing in front of the x on the formula. There we go. Reached our goal. Let's look at our vertex. Oh my goodness. Okay. I'll eventually be able to draw B. All right, so make sure you don't put -2, +5. It's got to be the x first and the y second. So 5, -2. Boom, there's our vertex. Now, since it's y squared equaling a negative, x squareds we know are up and down. So y squareds must be left and right. Since it's negative, it's going to open to the left. So let's go get p. So if we do, we set the 4p, right, equal to the number in front of the non-squared term. P equals -1. So we would go to the left one to get to the focus, and then to the right one to get to the directrix. So over here at 6. There we go. So this would be x equals 6. Okay, so now for how wide to make it. So our focal diameter that's going to be the absolute value of the number in front of the non-squared term. So we're going to get 4. So 4 divided by 2 is 2. So I'm going to go 2 up. And I'm going to go 2 down. And we have it. You know what did it just say to graph or did it say to find all those pieces? I can't remember. Oh, it did. Okay. So we only got I just realized this, you guys. We only got the vertex. We never really got the focus and the directrix formally. Okay. So you can see -1, 1 is where the focus is, but let's go through using the formulas, okay? So on this last one, sorry about that. On this last one, since it's the x being squared, that means everything's going to be happening to the y, right? Okay. So h comma k plus p. And for the directrix, it's going to be y equals k minus p. And this is if you just don't like to get it through the graph. Do we already have these things? It should be y equals 3 for the directrix, and it should be -1, 1 for the focus. But let's go ahead and do this using the formulas too. So -1, 2 are our h comma k. So -1, 2. The p that we got was right here, -1. So plus -1. Plus a negative is just a minus, right? So let's just make it -1. So that's going to give us -1, like we thought. And then if we do the same thing here, y equals, the k is the y value, so the 2, minus -1. So that's going to give us 2 plus 1, which gets us y equals 3. Can I fit it? Okay. All right, I apologize for forgetting to get that on the last one. Okay, now this one that we're on here, we should get it. Okay, so kind of running out of room on the screen here. Let's see, focus. So in our equation, it's y being squared. So everything's going to be happening to the x. So I'm going to do it to the h in this case, not the k. And then the directrix is going to be an x equals. Always the opposite. Instead of h plus p, h minus p. Okay. So we got for our, oh man, not going to be able to run into my work here. Apologize, you guys. Okay, so h, k are over here. H is 5 plus the p. The p was -1. So plus -1, that would just be -1, right? Notice this a little bit. I got it. And then comma the k, right? So the k was, if you go back to our vertex, -2. So that should get us 4, -2. For this one, x equals, so the h is the 5 minus p is -1. So that's going to give you a 5 plus 1, which gives you 6. And you can see that those match. We already knew it was x equals 6. We already know it was 4, -2 for the focus. So we are looking pretty good. Okay, I kind of ran out of space, so I probably won't do that second way of getting these extra points, you guys. I think using the focal diameter is going to be probably the quickest anyways. All right. So I've kind of shown you a few different methods, but I know that we have people who are like really into visuals or visual learners. And then we have people who are really into like, I just want the numbers, I hate graphs. So I was kind of trying to give you both so you could take the one that you want. Okay. All right, let's go in and look at our last problem, a word problem. An engineer designs a satellite dish with a parabolic cross-section. The dish is 15 feet wide at the opening and the focus is placed 4 feet from the vertex. Position a coordinate system with the origin at the vertex and the x-axis on the parabola's axis of symmetry and find an equation of the parabola. Well, they kind of gave us a picture, so we didn't have to think, but we should have been able to get that from the words that they gave us. So it says position the vertex on the x-axis and make the x-axis the axis of symmetry. So here's our satellite dish. Okay, at least the side view of it, right? All right, and then let's put the focus right here. And just make these. Okay. All right, so what we know is that this is going to go through 4, 0. All right. Just to like not have confusion. Oops. Darn it. Let's try that again. Just to not have confusion, let me make this a little bit better. Oh my goodness. All right, let me make it a little bit shallower so it doesn't run in. There we go. Okay. So I really want it to be clear in part B what's going on. Okay, let's see here. It's at the vertex, at the origin, 0, 0. So that means those first formulas. Now it's facing sideways, so it's not going to be an x squared. It's going to be y squared equals 4px this time. Now it faces towards the right, so we know that p is going to be positive. If it had faced towards the left, our p would have been negative. And our p is staring right at us. P is the distance from the vertex to the focus. So p equals 4 in this case. So we're just going to simply substitute that 4 in right here, and we've got it. Okay, so it should equal a positive because it opens right, and it's going to be a y squared because it opens right. All right, so let's tackle part B, which is definitely the harder part of the two. It says to find the depth of the satellite dish at the vertex. Okay. So it wants the depth. So what it's looking for in the picture, let me see if I can highlight that, is it's looking for this distance right here. And at first glance, you might be like, that's 4, right? But 4 goes all the way from the vertex to the focus, which actually lies outside of the dish. So we're not looking for that. So I just want to make sure it's clear that this from here to here is 4, but what we're looking for is just how deep this satellite dish is. Okay. So in other words, if we sandwiched it between 2 lines, how deep that would be. Okay. All right. So here's my thoughts. Let's go ahead and kind of draw what I'm thinking. What I know about this point right here, and even this point down here, is I know that this line is 15. This line is 15 long, right? I know that from right here. Okay. So if it's 15 feet, then it must be, if I divide it by 2, that we got 7.5 on both sides. So in other words, the ordered pair for this top one is some sort of x value, I don't know, comma 7.5. So I'm just going to put question mark 7.5. Similarly, for the bottom one, it's the same x value, negative 7.5. So some x value, negative 7.5. Now, that x value, that question mark, that's what we want because that's how deep this satellite dish is. That's what we're trying to find. So what we're going to do is we're going to take the formula that we got in part B, and we're going to substitute that 7.5 in for the y, and we'll solve for the x. We'll find out what question mark is. Okay. All right. So we're going to put 7.5 in. Okay. We're going to square it. So 7.5 squared is 225 over 4. Now, you know what? I'm questioning if I want to keep it fractions or not, but why not? All right. And then we just have to divide by 16. I'm putting the 16 in the denominator here. Then I need to put the 16 in the denominator here. Whatever you do to one side, you do to the other. Okay. So this is going to become 225 over 64. And that's going to be your answer. If you get that in your calculator, 25 divided by 64. .51. You can see decimals wasn't the way to go here. That's a long decimal, like 3.5-ish though. Let me put some approximates. I like to do that to check myself because we knew 4 was too big, but we're like, hey, it's pretty close to 4, you know, 3.5. That sounds pretty darn good. Okay. So that's going to be the x value that goes along with the 2 y values that we saw. All right, you guys, thank you so much for joining me. Good luck on your 7-1 homework. Take care.